Today's lesson is sums and products of rational and irrational numbers. So much of today's lesson is actually an investigation that will be conducted by you. We are going to investigate what happens when we take the sums and products of rational and irrational numbers in respect to closure, which we learned about earlier in this chapter. So for the opening exercise, it says with a partner, but you will be completing this on your own. You will complete the tables to answer the following. Are the sets of rational and irrational numbers closed under multiplication? And what about under addition? So you're going to see there's a table for 1, and then there's a conclusion spot underneath. There's a table for 2 with a conclusion underneath. And then there's a table for 3 with a conclusion underneath. So at this point, what I would like you to do is pause the video, and you're going to complete the opening exercises, 3 tables. When you are ready, please resume the video to check your answers. I will have the answers posted, and we will discuss the results. Okay, at this time you have completed the opening exercise, so we will now go through the 3 tables and look at the results and discuss hopefully what you were able to discover through investigation of these different combinations of numbers. So in number 1, it said we were going to examine the products of 2 rational factors versus irrational factors. So on the left side, you're going to see product of 2 rational numbers here. And on the other side, you're going to see the product of 2 irrational numbers. On the left-hand side, you can see in the boxes that I did simplifications. So when I simplified those, I was able to see that the rational numbers are closed under multiplication. If I take 2 rationals, I multiply them, I always get a rational. However, the irrational numbers are not closed under multiplication. You can see my one error, well, a couple errors. I have 2 irrationals here, but I don't have them here. I have rational numbers there. Okay, so at this point, if you need to change any answers to number 1, just pause the video until you're ready to go on to number 2. Now, if we look at number 2, we have a situation where we have the sum now, so adding 2 rational numbers versus adding or the sum of 2 irrational numbers. So looking at this, again, you can see I simplified in the blocks. You can see that rational numbers are closed under addition. When you take 2 rational numbers and add them together, you still get a rational number. However, on the other side, you're going to notice we don't have that situation. It does not stay irrational. We have a rational answer right there. So irrational numbers are not closed under addition. And then lastly, in table 3, we took the product of a rational and irrational, and we took the sum of rational and irrational. And what I want you to notice here is I really could have just asked you to do real numbers, because in the real number system, you're either rational or irrational, and if you take both of them together, that's just the real number system. So again, you can see my simplifications, and you see that I got rational or irrational for all of these. So that means the real numbers are closed under addition and multiplication. So now we're going to go through some always, sometimes, never questions to go ahead and finish summarizing what happens when we are checking for closure in these situations. So, based on your conclusions on the previous page and above, which of the statements is always true, which is sometimes true, and which is never true? If the statement is sometimes or never true, give an example to support your reasoning. So the first one, the sum of a rational number and a rational number is rational. So in other words, rational numbers are closed under addition, and we did find out that that was always true. In B, the sum of a rational number and an irrational number is irrational. So if we really want to go back and check it out, a sum of rational and irrational is always irrational. That's this table here on the right in number 3. So the answer to that is always. In C, the sum of an irrational number and an irrational number is irrational. So 2 irrationals added up. So if we go here, we remember I had the one exception that was rational. So this is going to be sometimes true. And if we want to have an example of that, we have the example of what we call additive inverses. So for example, if I take the square root of 2 and I add to it the negative square root of 2, I'm going to get 0, and 0 is actually a rational number, an answer. The product of a rational number and a rational number is a rational number. This is always, which we saw in our table. E, the product of a rational number and an irrational number is irrational. So we're going to go back up to product. Do we have rational and irrational? We do, rational and irrational right here in table 3. And we see that it is sometimes. We do have the exception of our example, which was square root of 2 times 0, which gives us 0, and there we see 0 is a rational number. And then lastly, the product of an irrational number and an irrational number is irrational. So that's irrational times irrational. So if we go back and look, that's this table in number 1 on the right, and we see there were exceptions to that. So again, the answer to this one is sometimes. And we have the example of, for example, square root of 5 times square root of 5. That was equal to 5. That's a rational number. Or we could have the one that was square root of 2 times 1 over square root of 2. That would be 1. So we're seeing that we can get a rational answer from that situation. Okay? And that concludes your lesson on sums and products of rational and irrational numbers.